4-inch total wide gap. So here, so you get 2 inches on sheathing, 2 inches on the concrete. And for everything you do, regardless of condition, when you get done, you want to make sure it's monolithic, void, and pinhole free is what you're looking for. So think of this as a completed system. It's an air and water resistant barrier. But I think of this, the sheathing is more so the water resistant barrier, and your joint treatment with accessories is completing the air barrier component of it, of the entire system. So when you're looking at it, you look at things through the lens of, is this going to be airtight, when you're treating the condition. So, treating sheathing joints, it's 1 inch on each side, so 2 inches total. Into the rough openings, so what you do is you 2 inches onto the sheathing, and then you want to treat just beyond where the interior air seal is going to sit for the window. So if the window is going to sit here, you want to treat a 1/2 inch to 1 inch beyond. And the reason is that, when I made this, I taped it off so that way it would be really clear, to make it easier to communicate the distances. But it's not going to look like this in the field. It's going to be wavy. So if you go 1/2 inch to 1 inch beyond, right, it accounts for that lack of perfect line that you're going to have. Because you want the interior air seal of the window to connect with the air barrier of our system. You want the window guy, when he comes after you, to be able to connect the air barrier there. So 2 inches onto the sheathing and rough openings for windows, and then a 1/2 inch to 1 inch beyond where the window's going to sit. So if you don't know where it's going to sit, it's just a coordination issue. You want to have that discussion. You might want to come up with a template or a tool, where you can custom cut, where you kind of lay it in and say, okay, the window's going to be here, and help you, achieve some efficiencies when you're deciding where to treat this joint. If you have movement joints, right, what you can do, as long as it's no wider than 1 inch, so 1/4 inch to 1 inch of a gap, I recommend that you put backer rod in it. Once you get much over 1/4 inch, you have to do a backer rod into it. And then same thing here, we were talking before some of you arrived. So pipe penetrations, right? Typically they're not exactly precision cut, but if you notice that a lot of penetrations on the project, you've got a lot of gaps, just make sure that the other trades are aware and cognizant, that when they're cutting through the sheathing, they're cutting through the water resistant barrier. And try and keep it as precision cut as possible. Keep it under 1 inch gap, when they get done. So if you do show up and there's a larger than a 1/4 inch gap, same thing, you fill it with backer rod before you treat it on the other side, like you see here. Corners, it's 2 inches and 2 inches. And what you see here, so this is just an example of what you'd have to do if you've got punch studs in your rough opening versus unpunched studs. So let's say, the window is going to stop here, right? So you would need to get a scrap piece of stud, most likely it's the metal you're going to find on the job, and then cut out a scrap around it and treat, and fill that gap. You have to have a solid backer, treat around and make that airtight connection. And this is meant to represent like connecting onto roof flashing, or not flashing, like a roof buck, wood buck. It's a dissimilar material, so it's 2 inches and 2 inches. The system overall, it's pretty simple. You just have to understand your thicknesses and your widths for the condition. The thickness of application for the liquid flashing is going to be a minimum of 16 mils, and we'll go over how to measure that. And that's for any condition. One thing that you'll find with this liquid flashing is that it wants to install on the thicker side of its requirements. So, there's nothing necessarily wrong with that. It's just using excess material. So, when you first get started, I recommend trying to get a feel. Take some time when you're getting started and, drag it out, test it like we're going to show, and get an idea to visually know what, 16 to 22 mils looks like. You're not going to hit 16 mils consistently everywhere. It'd just be a waste of time to try and do that, that level of precision. But my personal recommendation is, try and keep it within 16 to 22, 24 mils, and you'll be doing pretty good. Particularly when it's colder outside. Today we happen to be a little bit warmer, so it'll probably be a little easier, but we are in winter. So if you've got colder mornings or days, right, it's definitely going to be apply a little bit on the thicker side. So any questions over what I covered before I get started with the application of the accessories? So I loaded this to tube, but I didn't cut it. Show you what I do. So what you can do is you can snip that part off. What I do, just load it and just kind of poke some holes in it. a little easier, a little cleaner. So I've got some booklets here. So this has got recommended treatment or installation guide for the liquid flashing, or for the transition membrane in this book. So the recommended details. So the transition membrane that you see here, we're going to show making the connection from the wall to the slab. You can do transition membrane rough openings. You can do it at expansion joints. And you can also do it at connection to similar, which is what we're going to do, showing the wall to the slab. And this can, I personally would prefer to do liquid flashing for rough openings. You know, if you do it around the rough opening, I feel like it's slower and there's many more steps. There's a higher level of complexity. Liquid flashing is faster, lower level of complexity, easier to do, and more efficient. And then this other pamphlet is the details for how to treat with the liquid flashing. And then also in here is a technical guide, which I see that Juan has. But the technical guide will cover things like if you want to know about screw spacing, if you've got negative wind loads that you have to achieve, you know, if you have to do something greater than 8 inches on the center than you normally do. And then lastly, in these I put these wet mill gauges. So these wet mill gauges will be, you know, part of what you do for quality control. So to check the thickness of insulation for the liquid flashing, we'll demonstrate it when it's on the wall. You guys haven't seen these before. These have teeth on them with numbers, corresponding numbers. You know, it's about the size of a credit card. It's like that's 1 mil, so that's 6 mils, 14 mils to 30 mils. So this material we want 16 mils. So what you do, if you liquid flashings on the wall, you press it into the wall, pull it off, and then the last tooth that has material on it, that's what you know your thickness is in that area. So that's why I was saying, you know, consistently getting 16 mils. You know, if you sit there fussing with it, trying to get 16 mils everywhere, you know, you're probably going to spend more time than it's worth. So I recommend, you know, have a range that you guys are comfortable with and find acceptable. You know, like I said, 16 to 22, you know, 16 to 24. If you start getting above that, you know, you're a little on the thick side and just using too much material. Who are the guys that are going to be installing this in the field? These two? So definitely make sure that you guys have this, you know, just as a reference for yourself. And then I've got 2 others here.
Yeah.
So we use one of the people that study that.
Well, this first, that's for Sean. That's just the specs. I'll just keep it on somewhere.